Hello everyone. Today we are going to learn about program development steps in a programming language. That is, what are different steps that we do require for writing a programming language. So those steps we'll see one by one, right? So first, why do we require those steps for writing a program is in order to implement that particular problem. That is, if you are going according to the steps, and it will be easy for you to solve a problem, right? So the program development steps or phases is sequence of steps to develop a program in any programming language. That is, whatever the programming language it may be, we need to follow the sequence of steps in order to solve a problem. So generally, the program development steps contains 6 phases. They are as follows. See, PDS. PDS is nothing but your program development steps. In that, first one is you want the requirements. And the second one is you need to analyze or analysis. And step 3 is you need to design. And step 4 is you need to do coding. And then your step 5 is testing. And then your step 6 is maintenance. So we'll see all these different phases and how we are going to implement all these 6 phases in our program, right? So coming to our requirements. So first we need to find out what are the requirements for the problem. If I tell I wanted to add 2 numbers, right? Then I should know what are my boundaries. That is, what do I require for performing addition of 2 numbers. So what do you want the requirements? You can simply take 2 variables, and that sum will be that sum will be calculated and stored into another new variable. That is one method. And directly you can print a plus b. That is one method, right? So there are 2 different methods just for printing addition of 2 numbers. So first of all, you need to decide what are the boundaries of problem. That is according to the user, whether he wanted to consider 3 variables or he wanted to complete it in only with 2 variables. So those requirements has to be known first. So that is, we define the problem statement and we decide the boundaries of the problem. So according to the problem, you need to decide your boundaries. And next, information about the problem must be stated clearly and unambiguously. So whatever the statement you are taking from the problem, it has to be clearly mentioned. I wanted to perform addition of numbers. If I give a question like that, you will be confused. It is addition of 2 numbers, 3 numbers, 4 numbers, or 5 numbers, right? So such type of ambiguity should not be there in your problem. Next, we need to understand the problem statement and gather the preliminary requirements. So if I give the question properly that you need to perform addition of 2 numbers, then you need to gather what are the requirements. A, B, or some P and Q, whatever the values you wanted to take, those all has to be gathered. Main objective of this phase is to eliminate unimportant aspects and identify the root of the problem. So if the same addition problem when you are trying to do, I said addition and by mistake you had given subtraction symbol there. What it will happen? You'll get a wrong output, right? So that unimportant topics or the aspects has to be keenly observed in this, and you need to eliminate that one, right? And then next comes your analysis. So analysis is you are trying to analyze the problem, whatever the code you are writing or whatever the question you are considering. First, you need to analyze it. That is, all the factors like input, output, processing requirement, memory requirements, error handling, interfacing with other programs have to be taken into consideration in this stage. So in this analysis part, what did I said just now? I wanted to add 2 numbers, right? So what all 2 numbers? There may be integer value, there may be a floating point value, right? There may be some decimal pointed value or double floating point values. So that analysis has to be done by you before writing the program. That is for what you are writing the uh, program or algorithm or the code what you are trying to develop. That part is nothing but you are analyzing the problem. At the same time, you need to check out your memories also, and also you need to find if any errors are there. So all these things can be analyzed in the analysis phase. It also determines the required format in which results should be displayed. Yes, either the user wanted to give inputs at runtime, that is after compilation, execute while executing, if you will give an output, I mean sorry, input, then that is one type of programming. And if command line arguments are there, if you are providing some input values at command line, so that is another type of processing, right? So like this, different types of processings are there. You need to analyze what is the requirement of the user. And then next comes design phase. So here the software developer makes use of tools like algorithms and flowcharts to develop the design of the program. You know what is an algorithm? Algorithm is nothing but a step-by-step procedure to solve some particular problem, and flowchart is nothing but your pictorial representation of an algorithm. So these are the basic definitions. So when you are uh, solving or writing a program, first what you'll do, you will collect the requirements, and then you will analyze what is the problem, and then you will start writing algorithm or flowchart. And then next is coding. So after writing your algorithm or your flowchart, you will start writing your code. So once the design process is completed, converting algorithm to a program by selecting any one of the high level language that is suitable for the problem. So that is whatever the algorithm you had developed, that can be written in any high level language, right? That is suitable for the problem. That is either you are going for C, C++, or for Java or for Python. Which type of high level language you wanted to use, that can be taken after writing the algorithm. And then coding is generally a very small part of the entire program development process, and also a less time consuming activity in reality, right? If suppose I wanted to find out square root of some 99, or it will take some one second or 1 minute of time for the humans, right? The same thing if we will do in your system, within 1 second you will get the answer. So the consumption of time will be reduced, what we are trying to do in the reality. And next, in this process, we identify and eliminate all the syntax errors related to spelling, missing commas, undefinable labels, etc. So all your syntax errors, those all small basic errors when you are trying to write the program, has to be eliminated in the coding part. Next, for effective coding, some of the guidelines are to be followed. So the first one is use the meaningful names and labels of the variables. So see, if I wanted to do addition and I had given some name like integer, some movie name, or integer xyz, and second value is integer pwy. So if I'll take like that, it will be like confusing, right? So you have to give the proper meaningful names and the labels of variables. And the second one is simple and clear expressions has to be given. That is, a proper expression should be given when you're trying to code for a problem. Next, modularity with emphasis on making modules generalized. Modularity with emphasis on making modules is how you are trying to divide the particular program. Is nothing but your modularity, and making use of comments and indenting the code properly. So when you're trying to write the comments, it will be easy for the user to understand. And indenting is nothing but when you're trying to write something like loops. So the loop content has to be in within the loop. Like if you cannot start everything from left indent or right, either from right indent, but you need to follow proper spaces so that loop will be easier to understand the code. Look also, I mean, sorry, look of the program will also be nice, and it makes your code to be understandable a bit easier. That is, you'll be able to find out where the loop is going. Within that loop, what you are trying to execute and all, you'll be able to know. And avoiding jumps in the program to transfer the control. So you need to use very less jump statements, right? So if you will write the proper code properly and indenting properly, obviously jumpings will become less, right? So that we can avoid all those jumps and all, right? And then next step is nothing but your testing. So the testing is nothing but the program is tested on a number of suitable test cases, right? If suppose I had given integer a is equals to 10, b is equals to 5, right? So for the first time I had given a is equals to 10, b is equals to 5. So sum is 15. Next time as a test case I had given as 10.5 and 12.5 or else 2.5. So now what is happening? My test case value has been changed, right? So now what do you get? You will get a compile time, an error because you had declared the variable as integer and you are giving the value as a floating point value. So such type of different test cases has to be done when you will write a program. Next, a test plan of a program has to be done at the stage of program design itself. So when you are considering those test cases, all those has to be considered while you are designing the program only. This ensures a thorough understanding of the specification. If you will take different test cases in the design part, you will be able to understand the problem completely. Next, running the program several times using different set of data verifies whether the program correctly works for every situation provided in the algorithm. So whenever you're taking different test cases, you will come to know whether that particular algorithm or the code which you had written is working perfectly in all the situations or not. As I said, if I declare the variables as integer, and I had given a is equals to 10, b is equals to 10, then answer will be 20. If I will give a is equals to 100, b is equals to 200, then my answer will be 30, right? If I'll give something like 11.5 and 12.5, then my answer will be some 33 point or 34, right? But the thing is you had declared it into an integer and you are trying to give a floating point value, so that where you can tell that it is not going to work for the floating point value. So such type of situations occurred in many of the programs. Those can be corrected, right? And it is always useful to include the maximum and minimum values of all variables include. So you can take the maximum and minimum values for all for doing those test cases, right? And then next comes your maintenance. Why do we require maintenance? So as I had said, once I wanted to write addition of two numbers, second time I wanted to write addition of three numbers. So then what can I do? If I maintain the code of addition of two numbers properly, I can simply modify the addition of three numbers just by adding an extra variable. So updating and correction of the program for changed conditions and field experiences is accounted for in maintenance. So if you are able to maintain it properly, updation or changing in conditions will be very easy. And maintenance becomes essential in the following situations. First one is change in specification. Second is changing equipment. Errors which are found during actual execution of the program, right? So these are the three different situations where maintenance actually helps a lot. As I said, till now I had written program for integers. Now suddenly I wanted to convert that into floating point value. Then what can I do? Simply I can just change the data type to float. So such type of things can be done if you'll maintain your code properly. So these are different programming steps that we are going to use when you are writing the program, right? So that's all for this video. Thank you, everyone.